Hey there, and welcome. So, you've seen those headlines everywhere, right? Drinking more coffee is correlated with living longer. Or that really weird one, ice cream sales are correlated with shark attacks. But what do those numbers actually mean? Well, today, we're going to crack that code. We are going to learn how to read the numbers so you can tell what's real and what's just noise. Let's jump in.
First up, we'll get our heads around the big idea. What even is correlation? Then we'll learn how to decode the two most important clues, its strength and its direction. After that, we'll dig into the nerdy stuff, how to tell if a finding is legit or just a random fluke. And finally, we'll wrap up with a one single golden rule of correlation that you absolutely have to remember. All right, let's start with the absolute basics. Before we get into any of the math, what are we even talking about when we say two things are correlated? You've definitely noticed this in your own life. I'm sure of it. Like on days you get a good night's sleep, you just feel way more focused at work. Or how when the summer heat really kicks in, suddenly everyone is buying ice cream. If you've ever spotted a pattern like that, congrats, you're already thinking about correlation.
And that's really all it is at its heart. Correlation is just a fancy statistical tool that measures the relationship between two things. It doesn't tell us why they're connected, just that they are. When one of them changes, the other one tends to change too. They vary together.
Now, these relationships can go in two different ways. You've got your positive correlation, where everything moves in the same direction. One goes up, the other goes up. Think height and shoe size. But then you have negative correlation, which is more like a seesaw. They move in opposite directions. As one goes up, the other goes down. And here's a perfect real-world example of that negative correlation in action. If a weight loss program is actually working, the more time you spend doing it, the lower your body weight should get. See? One variable, time, is going up, while the other, weight, is going down. They're moving in opposite directions. Okay, so this is what you'll see out in the wild, in a research paper or a news article. It looks kind of like alien code, right? But I promise, every little piece of this tells a story. And by the time we're done here, you are going to know exactly how to read it. So let's get into it. We're going to start with the first two pieces of this puzzle, figuring out how strong the relationship is and which direction it's moving in. To figure out any correlation, all you need to do is check four things, and always in this order. First the number, then the sign, then its significance, and finally its real-world impact. So let's tackle those first two right now. First things first, the strength. Now for just a second, I want you to completely ignore that little minus sign. Just pretend it's not there. We're only looking at the number, 0.80. This number tells us how strong the connection is. So correlation values are always on a scale from 0 to 1. 0 means absolutely no relationship at all. 1 means a perfect, flawless connection. Our number, 0.8, is really, really close to 1. So the big takeaway here is that we're looking at a very strong relationship.
Okay, so we know it's a strong relationship. Now we can bring back that little minus sign we were ignoring. That sign, whether it's a minus or a plus, tells us the second key piece of information we need, the direction.
And honestly, it's that simple. A minus sign just means it's that seesaw, the negative correlation we talked about. The two things are moving in opposite directions. If there was no sign or a plus sign, it would mean they move in the same direction. So we've already decoded the first half. We have a strong negative relationship.
Now, let's get to the slightly more advanced stuff. Because it's not enough to know there's a strong connection, we have to ask two more questions. Are we sure this isn't just a random accident? And, how much does this relationship actually matter in the real world? This brings us to the second part of our code, that little p. This is the p-value, and it tells us about statistical significance. Basically, think of it as a fluke detector. It helps us check if our finding is the real deal or just a coincidence. So the general rule in science is that a result is significant if that p-value is less than 0.05. All that means is there's less than a 5% chance, or 5 in 100, that the relationship you found is just random noise. But check out our number. It's less than 0.01. That's even better. It means the probability of this happening by pure chance is less than 1 in 100. So we can be more than 99% confident that what we're seeing is a real relationship, not some statistical accident. Okay, one last piece of the code to crack. We know we've got a strong, real, negative relationship, but how big of an impact does it actually have? To figure this out, we calculate something called the effect size. It has a super technical name, the coefficient of determination, but don't worry about that.
All you need to know is how to find it. All you do is you take that R value and you square it. You multiply it by itself. So we take our negative 0.80, multiply it by itself, and we get 0.64. You can think of that as 64%. Okay, but 64% of what?
It means that 64% of the change we see in one variable can be explained, or predicted, by the change in the other variable. That is a huge amount of explanatory power. But it also means that 36% is still a mystery. It's being caused by other factors we don't know about. And that brings us to our final and by far most important lesson. Okay, so we've cracked the entire code. We know how to read the numbers. But all of this knowledge is totally useless if you don't understand this one crucial, unbreakable rule. Let me say that one more time, because if you remember nothing else, remember this. Correlation is not causation. Just because two things move together, even if it's a super strong connection, it does not mean that one is causing the other. The reason is that a correlation only tells you that a relationship exists. It never tells you why. There could always be some other hidden factor, a third variable, that's secretly pulling the strings on both. Maybe ice cream sales and shark attacks both go up in the summer simply because it's hot outside. The heat is the real cause, not the ice cream. So now you have the tools. You can look at a statistic like this and know exactly what it means. A strong, significant, real-world relationship. But the real skill, the true secret, is looking beyond those numbers and asking that critical question. What else could be going on here? What's the story that these numbers aren't telling me? That's when you go from just reading data to truly understanding the world.